Hi ladies, this is the continuation of lesson 6.3. So in this video we're going to talk about composition of functions. Last video we talked about the operations of functions where we were adding functions together in order to get a new function. But here we're going to take the function of a function. So instead of just taking the function of x or some variable, we're going to take some independent variable. We're going to take the function of another function of some variable, some independent variable. So if you look at the definition of composition, which we defined last lesson, but the composition of function g with function f, or we could say g composed with f. We could also say f of g. And we read that function f of g of x, or we write it f of g of x. So the domain of that composition of the function is the set of all the x values where x is in the domain of f and f of x is in the domain of g. So the domain of f, that's our independent variable, that's our input. And after we compute f of x, this is our y value, that's our range. Now to take the function g of f of x, we compute f of x first. So we choose some independent variable, then we get an output, that's our range of the function f. The range of the function f becomes the domain of function g. And then the output of that, g of f, becomes the range of function g. So let's look at a couple examples. So the first one, we're looking where f of x is 6 to the negative first power, and g of x is 3x plus 5. So we have to find the following. First, we're finding f of g of x, or g composed with f. So in this first function, g composed with f, we have to figure out what function g is first, and the range of function g is going to be the domain of function f. So with that in mind, we know that f of x is 6 to the negative first, which is 6 over x, and g of x is 3x plus 5. So in order to find f of g of x, or g composed with f, we are going to substitute 3x plus 5 in for the independent variable of function f. So function f of g of x equals 6 over 3x plus 5. So let's now look at the domain of f of x, and let's look at the domain of g of x, where we can get a defined function within the set of real numbers. So f of x, the only restriction here is x cannot be 0. Because if x was 0, then the function would be undefined. But in g of x, x can be any real number. So now looking at f of g of x, the domain, this cannot be 0. So therefore, the restriction that we have is 3x plus 5 equals 0. This is our one exclusion within the set of real numbers. So therefore, x cannot be negative 3/5. So we have defined our range for function f of x. We've defined our we've defined our domain for function f of x. We've defined our domain for function g of x, and therefore we can define our domain for function f of g of x, or the function g composed with f. So using those same functions, g of x is 3x plus 5 and f of x is 6 to the negative first, let's look at the function f composed with g. So in this function, f composed with g, the range of function f becomes the domain of function g. So here we're going to compute f of x first, and that's going to be our independent or our input for the function g. So now in this case, we'll look at g of x, or sorry, we'll look at f of x. So f of x is 6 over x, and g of x is 3x plus 5. So g of x is 3x plus 5. F of x is 6 over x. Now the domain for g of x and f of x, those domains remain the same, where in g of x, x can be any real number, and in f of x can just not be 0. But the domain of our function, of our composition, may change. So let's look at that. So g of f of x equals 3 times, now remember our independent variable or our input for x is the output of f of x. So 3 times 6 over x plus 5. So our g of f of x is 18 over x plus 5. So here, x cannot be 0. A g of f of x is undefined. If we have 18 over 0 plus 5, that number is undefined. So here, x cannot be 0. All right, now let's look at the last composition, where we compose f of f. So f composed with f is not the same as f of x. So we're going to look at function f of x, which is 6 over x, or 6 to the negative first. 6x to the negative first, and then f of x again is 6x to the negative first. Now when we take f composed with f, we're going to take the range of f of x and use that as the domain of f of x. So we're going to do this function twice. So here is our input for the second f of x function. So we're taking 6x to the negative first, where our x is now 6x to the negative first. That is our function f of x. So here we have to apply some properties of exponents. So 6 times x to the negative first, all to the negative first power. We have to distribute that negative first power. So we have 6 times 6 to the negative first times x to the first, because negative 1 times negative 1 is positive 1. And so when we simplify this, we have 6 times x all over 6. Because when we move this 6 to the denominator, the exponent changes signs. So 6 times x over 6, which is just x. So now let's think of the domain that we can have for f of x, of the composition of f of x. And the result of that function is just x. Therefore, in order for x to be a real number, the domain is all real numbers. So just to summarize for the domains, so looking at function f and looking at function g, in function f of x, the domain is all real numbers except 0 because you can't divide by 0. If you do, you get undefined. G of x, the domain is all real numbers. When you take the composition f of g of x, or g composed with f, the domain is all real numbers except negative 5/3, because when x is negative 5/3, then when g of x is negative 5/3, then the function is undefined. G of f of x, or f composed with g, the domain is all real numbers except for 0. And then lastly, f composed with f, the domain is all real numbers. Try this next one on your own. You can pause the video while you work, and then when you unpause, I will reveal the solution. So you're looking for f of g of x, that composition, then g of f of x, and then f of x. After you've computed the composition of each function, or each set of functions, then I want you to define the domain of each composition. So what can x possibly be, or what values of x are excluded in order for the function to be defined. So let's look at this first example. F of x is 5x minus 4, g of x is 3x to the negative first power. So this 3x to the negative first power is my input in function f. So that's 5 times 3x to the negative first power minus 4. 3x to the negative first power is 3 over x, if you remember your properties of exponents. So f of g of x is 15 over x minus 4. Therefore, the domain is all real numbers except 0. X cannot be 0 because if x is 0, the function is undefined. All right, let's take a look at the second one, g of f of x, or f composed with g. So here we have the range of f is the domain of g, so whatever the output of g of f is, that's the input for g. So g of f of x is 3 times 5x minus 4. So the output of f of x, that is our input of g of x. So therefore, g of f of x is 3 over 5x minus 4. Now 5x minus 4 cannot be 0 because if the result of 5x minus 4 is 0, the function is undefined. Therefore, the domain here in g of f of x excludes x being 4 of x. And then in the last example, f of x, where f of x is 5x minus 4 and f of x is 5x minus 4, the function f composed with f is 5 times 5x minus 4. So this 5x minus 4 is the input for function f. So the output of the first function, f of x, is the input for the second function, f of x. So the function f composed with f equals positive 25x minus 24. So there are no restrictions in order for this function to become up to a real number. So the domain here is all real numbers. So just as a summary, looking at the function f, the domain is all real numbers. g of x, the domain is all real numbers except for 0 because you cannot divide 3 by 0. F of g of x, the domain is all real numbers except 0 because the f of g of x is defined as 15 over x minus 4. X cannot be 0. In g of f of x, the domain is all real numbers except for 4/5, because if x is 4/5, then 5x minus 4 is equal to 0, and that would be an undefined function. And then lastly, f of x, the domain is all real numbers, because any value of x will give you a real number when the function is defined as 25x minus 24. So please jot down any questions that you have, and we'll go over them next time I see you in class. Thank you.